In this video, we'll be utilizing geometry rules to find the exact area under a curve. Now, until we identify the appropriate way to analytically solve the area under the curve, again, without having to use the limit definition, this is the second best guess to evaluate, not approximate, evaluate the area under a curve if we've got A, some nice straight lines that are very obvious creating of a triangle, or unless we have a nice circular path. Now again, this isn't stated here, but it should be that this here is a half circle. So if I was going to go ahead and identify some areas of this function, I'm going to go ahead and start by evaluating the areas of each individual piece. So if I look at the area of the value from -4 to -2, so that's starting here and going to here, you'll notice that if I were to go ahead and draw a line here and a line over, then I'm going to have myself the area of a triangle. And the area of a triangle is nothing more than 1/2 base times height. So if that's the case, my base here is obviously a distance of 2. Again, the distance from here to here is a distance of 2. So I'm going to have 1/2, my base is 2, and the height of this is going to be simply this distance here, which you'll note is 1. So that's going to be multiplied by a value of 1. So the area in this space right here, if I were to again draw a line here, draw a line over here, that triangle is an area of 1. That might be good to know. I'm going to denote that A1 is 1. So I'm going to call this space right here A1. Now A2, I'm going to call this whole entire half circle. The area in this half circle, A sub 2, remember the area of a half circle, or let's say a circle, first off, is simply pi r squared. So if that's the area of a circle, the area of a half circle is going to be 1/2 of that value. So let's go ahead and figure out if this is the center, then the radius is going from here to here, which is a distance of 2. So that means that the area of the second space is simply going to be pi, my radius value is 2 squared, divided by the fact that I'm cutting this circle in half, 2. So that provides me with canceling those values out, 2 pi. So the area of the second section is simply 2 pi. And again, that's the area in this space, in this provided region here. Lastly, if I look at these last two sections, I'm going to cut this this triangle in half, and I'm going to go ahead and slice it this way. So now I have two what looks like equal area triangles, which again I'm going to find those the exact same way I did that A sub 3 and there's A sub 4. A sub 3 is the 1/2 base times height, so it's going to be 1/2 times 2 times 2. Again, A sub 3 is 1/2 base times height, and A sub 4 ends up being the actual same value. So in this case, those two, again, 1/2 and 2 cancel out, leaving me with an area value of 2 for both of those. So these are the areas based on appropriate formulas. Now, some other possible area formulas you might find is the area of a trapezoid, which you should identify from the last videos, that this is 1/2 times height 1 plus height 2 times the base, again, however we want to see fit to do that. We might have the area of a rectangle, which again is just simply base times height. And there's a few other ones that you might want to look into, but the majority of formulas that we're going to play with are, again, triangle, circle and half circle, and then the trapezoid and the rectangle. So these area formulas will allow us to evaluate, not approximate, any area under the curve that appears like one of these four options. We're going to use these formulas to answer the next following questions.